0.2 kilogram, and that is the mass of the liquid. What will now be the mass of the tank when filled with petrol? Mass of tank when filled with petrol will be, which is going to be equal to 43.2 kilogram plus 10 kilogram. Where are we adding 10 to it? The question says an empty 60-liter petrol tank has a mass of 10 kilogram. That is the mass of the tank. Then the liquid inside is this. So all together, it now give us mass of tank when filled with petrol. It now be the mass of the liquid together with the mass of the tank all together. And what we are going to have is going to be, that is 53.2 kilogram. 53.2 kilogram. Question number 3 says the mass of a specific gravity bottle is 15.2 gram when it is empty. It is 24.8 gram when filled with kerosene and 27.2 gram when filled with distilled water. Calculate the relative density of kerosene. From that question, we are having 15.2 gram. 15.2 gram. Another thing from that question is that apart from the mass of the empty bottle, we are also given 24.8 gram when filled with kerosene. So we are going to have that when it is being filled with kerosene, mass of specific garbage bottle plus kerosene. What we are given there is 24.8. 24.8 gram. That's another thing. Those are the values we are having there. We are told that when it is being filled with kerosene, and we have 27.2 gram when filled with distilled water. Mass of gravity bottle plus water. The value we are having there is 27.2. What is now going to be the relative density? We are told to calculate the relative density of kerosene. So what are we doing? The relative density will be equal to, once we are calculating for kerosene, okay, then the relative density of kerosene will be equal to mass of kerosene all divided by mass of equal volume of water. Mass of kerosene over mass of equal volume of water. And what will be the mass of kerosene? We are told empty bottle, this value. Mass of empty bottle and kerosene all together. So how do we now get mass of kerosene? It's going to be that of empty bottle and kerosene, which is 24.8 minus 15.2. Okay, that's that. The mass of equal volume of water will be equal to mass of specific gravity bottle plus water minus that of empty bottle, which is going to be 27.2 minus 15.2. 24.8 minus 15.2, we have 9.6. 27.2 minus 15.2, we have 12. So altogether, 9.6 divided by 12, we have 0.8. And that is the relative density of the kerosene. Question number 4. A cube of side 0.1 meter and freely on the string. What is the up thrust on the cube when totally immersed in water? We are dealing with cube. We have a cube. And when we are talking about cube, we have a volume, which is the length, the breadth, the height. So the volume is length times breadth times height. We are given the value for a side of a cube, just one side. And once we know the value for a side, automatically we have already know the value for the other dimension. And for a side is 0.1. This is 0.1, 0.1, 0.1. Okay? So this is 0.1 times 0.1 times 0.1. Okay? You can even say this is 0.1 times 3, and that's the volume. You can leave it like that. We have to calculate the up thrust. The up thrust, after I've told you the other time, will be equal to density, volume, and your value of G. We need the volume of the object, but we are not given. Okay? We are not given. And this is what we have calculated. We calculate the volume from a side that has been given to us. Automatically we can get the up thrust. So the up thrust now, let's say the density has been given, which is 1000 kg per meter cube. Put it there. Density 1000 times volume 0.1 times 3, then times 10 altogether. And this is what we are going to focus upon. You can multiply this straight away. 1000 times 0.1 times 3 at the same time times 10. And what we are having here is 3000. And this is equal to 1, 2, 3. 3.0 times 10 is to the power 3 Newton. And that is the up thrust that will be exerted on the cube. Question number 5. A solid weigh 10.0 Newton in air, 6.0 Newton when fully immersed in water, and 7.0 Newton when fully immersed in a certain liquid X. Calculate the relative density of the liquid. In this case, the relative density will be equal to, once this one is talking about the Archimedes principle, we are going to have loss of weight in liquid divided by loss of weight in water. Or it can be equal to up thrust, because up thrust is the loss of weight. Up thrust in liquid divided by up thrust in the water is the same thing. Up thrust in liquid divided by up thrust in water. Let's take it one by one. Loss of weight in liquid is going to be, you are going to subtract the weight in here minus the weight in liquid. For that of water, the weight in here minus the weight in water. Let's look at the value from our question. A solid weigh 10 Newton in here. Okay? For that loss of weight in liquid is going to be 10 minus, then what is the weight in liquid? We are told liquid X. 7.7 when fully immersed in a certain liquid X. That's minus 7. What about water? Loss of weight in here still remains the same, which is the same 10 minus, then in water, let's look at the question again. In water, we are told when fully immersed in water, which is 6.0 Newton minus 6. And that's the so this minus this, that's 3. This minus this, that's 4. We are going to have a value for the relative density. It is 3 divided by 4 will give us 0.75. and that is the relative density, 0.75, and that is the solution to question number 5.